right, it's 12 o'clock, so we're gonna go ahead and start. That clock's a few minutes behind right there. Want to thank everybody for joining us. Both, I don't need. Oh yeah, actually, thanks. Both here live in the room and on the web too. My name is Wayne Welk, automation specialist with the Reynolds company. Joining me today is Rob McGlynn, senior automation specialist with the Reynolds company. He's and drive specialist. So he will present for us today. We got a couple of quick introduction slides, as we always do. Hold on a second. It is. There we go. Yep. All right. So real quick, we always talk about what's coming up next. And September is our topic will be hazardous location products. So again, a lot of you guys are kind of new joining us today. This year we've been kind of rotating different domains, as we call them. So today is a power topic. This will be a components or an industrial control topic. And then in October, we go back to automation. So hazardous location products, of course, a little introduction to the portfolio of Rockwell's hazardous, suitable for hazardous locations. October, we'll kind of get back to automation and automation Studio 5000 update, as well as process control updates. That's really kind of a lot of information around the new Plant PX 4.5 update that just kind of came out or is coming out, as well as Studio 5000. If you guys haven't been up to date with Studio in a while, they're up to version 31 currently. And of course, 32 is on the radar at some point here soon. Missing November because November, of course, is Automation Fair, which we will show on the next slide. And in December, we've kind of done this now a couple years in a row, so we call it Best in Show 3, and that's our Automation Fair review. So we'll walk the show floor and we'll kind of report back, like kind of what were the cool things that we saw. Of course, a lot of it is kind of what's coming up in 2019. New product releases coming out. So speaking of Automation Fair, it's hard to believe. November still feels like a long ways away, but it's only 3 months away. And Automation Fair this year is in Philadelphia. And the 14th through the 15th of November. I think it's always the week before Thanksgiving, of course. So Thanksgiving is very close as well. There will be a travel package. We typically do a travel package. So if you guys are interested in attending this year's fair, reach out to your account managers with the Reynolds company. And the travel package usually includes the airfare and a hotel and all the transportation to and from all the places you got to get to. And I think that is it for me. Yep, just to introduce our topic today. So, it's just kind of good to see because we called it back to basics, and we were kind of chatting in the room beforehand. And, I think a lot of times we kind of forget, just some of the basics, right? We kind of tend to always talk about new stuff and new technologies and all the new buzzwords that are kind of out there, which is good to know and important too, to keep up with what's happening in the industry. But a lot of times we kind of forget that sometimes it's just going back to basics and refreshing our memory on things, or maybe you've never touched a drive before. So we'll do more of these, I promise, as we go throughout here in the future. So with that, I'm going to turn over to Rob to do a few little introduction slides on VFDs, and then he's going to actually do a live demonstration as well. We'll push our luck today.
Thank you very much, Wayne, our MC for today. Everybody, thanks for coming. Thanks for having me here. In keeping with the spirit of this presentation and to protect the timeline, this is going to be just a brief introduction to drives. It's not going to be a deep dive by any means. We're just going to hit the high points. Then this drive right here, we're going to configure over Ethernet using the drive software. So we'll try to keep within the hour. Start off, what is a VFD? And like I said, this is going to be very basic. It's a device we use mainly to control the speed of a motor. And with that, we can also use it to control the torque and control, talking about speed, we can control the speed of a conveyor, a fan, a pump. We can control torque on a winder line or some type of follower device. And really there's a million applications for a drive. The purpose of it, control the speed is number one. And kind of as a sidebar of that, we're going to also control how much energy we use, or we're maybe not necessarily control it, but we're going to reduce the amount of energy we use, just because the drive is going to run as fast as it needs to run and use the energy that it needs to run that fast. It's not going to run wide open all the time like an across the line starter. This is a basic schematic that I put on here just so the electrical engineer types in the room and online can see this. The rectifier is what takes the energy in from the utility. We rectify that into DC and store it on a capacitor bank on the DC bus. Then the inverter section is what we actually control. With the inverter section, we fire the output semiconductors in order and create a pulse width modulated waveform that makes an implied sine wave. And this is a little better shot on the bottom right-hand corner of the screen. You can see the output current and the waveform. The pulses are what the drive is actually putting out. And mathematically, you add all that together and you get this implied sine wave. And this is just a bigger shot of that same waveform. And by varying the speed of these pulses and modulating the pulse width, we can vary the AC frequency of this sine wave. And that's where we get the control from. Potential problems is something that we always want to hit on. A lot of people are scared of drives and don't really want to just jump in because of these things. Improper circuit design. This can happen, believe it or not, I have seen it before here in South Louisiana. Whenever you're applying one of these drives, you have to keep in mind what you're doing. There's inputs and outputs, and there's the AC in and out. It's not difficult. It's all in the user manual, and you do have a lot of help. There's Rockwell Tech Support. There's Wayne and I here to help. And we have a lot of online training classes that we offer as well. Harmonic distortion, we're not going to go deep into harmonics here, but I'm just going to make you aware of it. With this AC switching sine wave that the drive is creating, there is some harmonic noise that gets generated back into the power system, and it can be an issue in some cases. Safety, because the drive is usually located remotely somewhere other than the motor, you have to be particular about when you start it because you're creating motion. If someone's out there working on the motor or the gearbox or something, or working on a conveyor, there's potential for someone to get hurt. So that's our safety moment for today. And the microcontroller programming. This thing is not just something you buy and take out of the box and install and let it rip. It does have to be configured. The configuration is not difficult, and we're going to go over that briefly here. And I'll show you how simple it is. Keep track of that. Why use a drive? Right, there's energy savings. Over the last, I'd say about 5 or 6 years, I've seen a lot of people in applications where they really don't need a VFD because the motor runs at 60 hertz all the time. They're still taking out what they have there and putting drives in just for the sake of energy savings. And I've seen cases where they paid for themselves in 6 months. Generally, it'll take a whole year before it pays for itself. Improved process control. You can get a lot tighter control with this by controlling the speed of the pump instead of just pumping and deadheading against a valve and trying to control that way. And of course, there's the interfaces into PLCs and the DCSs, all the networks. Somebody have a question? Oh, okay. All right, and the two of the load types that we'll talk about here. Centrifugal loads, what we call normal duty, and constant torque loads, what we call heavy duty. There's different ratings for the drive. If you need X amount of horsepower, the drive can have 2 different ratings. And the heavier duty rating just means it's a little bit bigger box of amps. So when we size the drive, we always keep in mind what type of load we're going to be pushing. A constant torque load would be someplace where the drive is starting into a heavy load, like a fully loaded conveyor. PD pumps, extruders, and extruder is a particularly brutal application for anything. And normal duty drives, centrifugal pumps, fans, centrifugal compressors. Typically on a centrifugal compressor, we still use a heavy duty drive just because sometimes it will see a pretty good load. But also the overload ratings are changed. See, normal duty, it's 115% for a minute. Heavy duty is 150% for 1 minute. Reflected wave. This is a phenomenon that you see with drives. And when we started widely using drives in chemical plants, everybody got a pretty hard lesson in the reflected wave phenomenon. It's an effect to where the low impedance of the motor cable and the high impedance of the motor actually causes a ringing effect, or a wave to be reflected back, and it amplifies. So that reflected wave coming back, it can ring back and forth and get up as high as 2,000 volts, or let's think about that more specifically, about 16 or 1,700 volts is generally what it can ring up to. And the effect gets worse the longer the cable is. So the thing about the motor leads, whenever you call and you want to buy a drive, when you want help specifying one, we're always going to ask you, how long are these motor leads? So we can help with that. There's ways to mitigate this effect. It's just a matter of putting filters on the output of the drive. So there's always a way to deal with it. And this is just a good picture. I thought this was a cool picture showing the voltage doubling effects. Here it talks about cable lengths greater than 30 to 50 feet. The effect will be there at 30 to 50 feet. It's generally not something that we need to worry about. It's when it gets out further. On a small drive, it might be as close as 100 feet where we start applying filters. Larger drives, it might get up to 200, 300, 400 feet. There are charts that kind of guide you on this. Typically, I'm a little more conservative than what the charts say. I'll apply filters a little sooner than, or at a little bit shorter distances, because the filter is really just cheap insurance. And I thought this was a good example of a sound wave hitting a wall and bouncing back. And with the blue line, you can see how the sound is amplified, or the amplitude of the wave is higher. I just thought that was a pretty cool slide. And that's it for that part, just this basic intro. I'm trying to get through this quickly so we can get to the demo. All right, this part, shows the PowerFlex drives portfolio. This is kind of a salesy part of it, so I'm going to blow through this one kind of quickly as well. We're not going to do a deep dive into sales here right now. Come on. All right, the drive portfolio. These are what we call the component class drives. And the three you see, well, the first one is a PowerFlex 4M. This is an older model that is still available, but we don't talk about that too much. The three on the right are what we're going to talk about. The PowerFlex 523, 525, and 527 are the three drives, the three main drives in this component class. And they have different abilities, and we'll talk about that a little bit later. And these are what we call the architecture class drives. The PowerFlex 750 series, this is the flagship, and it has two drives in this portfolio, the 753 and the 755. And 755 is what we're going to be doing the live demo of in a little bit later. And the PowerFlex 7000, this is our medium voltage drive. This goes up to 32,000 horsepower. After that, it'll get a little bit custom. We can make it as big as you want, but up to 32,000 is just standard part numbers. Go with that? And the software that we use to configure this drive, Connected Components Workbench. This software is a free download. And I think it's a pretty good package. I've been using it for years, and I really like it, and we're going to show you all about it. And for everybody that's, I'm going through this kind of quickly just to stay on time here. Anybody who wants a deeper dive on this, I'm going to be here in this room. I can be here all day as long as you need. Or if someone wants to contact Wayne or I, we can come to you and we can meet at your office or our office, wherever you'd like. But we have plenty more information on this, just not all during this hour. But automatic device configuration. These devices can be configured when connected to a Logix controller, compact Logix or control Logix. It can be configured so that the controller holds all the configuration that's in the drive, and the controller will pass that configuration down to the drive. All right, so this is a standard feature on the 755 and 525 and can be added to the other drives that don't have Ethernet ports built in. It's just a matter of putting a card in there and they'll all work. All right, this is a cool video. So a drive gets smoked, something happens, someone replaces it. The Ethernet switch sends the IP address, the controller sends the firmware, then the controller sends the configuration, and the drive's ready to go back into service. That's my down and dirty display of automatic device configuration. Now we'll get down a little bit to the meat of what these drives are. How are we doing on time here? It's what? Oh, okay. Right. The PowerFlex 523. This is a simple, small drive. This 520 line goes up to about 30 horsepower. The 523 has no Ethernet module. It takes an analog speed input and has a few I/O points, so you can turn it on and off and do what you need to do with it. Just very simple, very cost-effective drive. The 525, this is the one that we really sell the most of. It has more I/O, embedded Ethernet, and built-in safety. So you can do SIL 3 safety in this drive if you choose to do so. And the 527 is a unique drive. This one doesn't really have configuration inside the drive. This drive's configuration is all inside of the Logix controller. So this drive is designed to work with a Logix controller. And for something like high-speed machine control, you can do a really cool integrated drive system with this thing. And we get into the architecture class. The 755 is the flagship drive with all the bells and whistles. The 753 is a general purpose high performance drive. Any fan, pump, conveyor, probably 99% of applications, you'll use the 753. The 755 has additional stuff for pump jacks, torque proving, more precision torque control, permanent magnet motors for doing motion control, and a few other features. Get to what I need to get to here. The PowerFlex 6000, this is a new addition to the line in the medium voltage line. This came in about 2 years ago. And this one, this says up to 2,600 horsepower. I think now that line has been extended to 3,000 horsepower. This is a PWM drive. So this drive this is a cascaded IGBT drive, voltage source drive that works just like all the competitors. And it's lower cost. Really that does it for a lot of people once you say lower cost. And the 7000, this has been our flagship medium voltage drive for a long time. This one has extremely precise torque and speed control. And we can package this drive in a lot of different configurations. We can do synchronous bypass, synchronous starting by having one drive and a lineup of starters where we can take one motor and bring it up to speed, switch over to bypass, then switch in another motor, use the drive to bring it up to speed. And so we can run several motors independently with this same drive, with this one drive. All right, questions on this? I know I'm going through this quickly, but I'm really hoping to bring up some questions.
Online, guys, too, you can feel free to type a question in the chat window. We can even unmute your line, too, if you'd like to ask it live. I think,
go ahead.
I think Rob's going to fire up an image now and do some of the drive configuration stuff. So that was quick.
Yeah, I already had it on. All right, folks, if anybody has a question, just stop me and let me know. I'm always really concerned about the timing with these things, and I tend to go through it really fast. But this is the Connected Components Workbench software. This is just what it looks like whenever you start it up. Really no frills to it. And on the table here, we have a PowerFlex 755. Now, this drive is a demonstration unit. And because it's a demonstration unit, it has all the bells and whistles. You have the camera on this way? All right. Because this is a demonstration drive, it has a lot of bells and whistles in here. Inside here, there's 5 slots for option modules. This is the main control board, and all the rest of these are option modules. Typically, you'll have this main control board and this one I/O module right here. But all of this is an encoder card, an auxiliary power supply card, a safe speed monitor card. I don't know, whatever that card is back there. I don't even know what that one is. But there's a lot of stuff going on here. This drive is already pre-wired to this potentiometer. We're going to use that to control the speed. And the red and green buttons here are for stop and start. We're going to set that up. So we're going to do just a bare basic drive startup here. Take us back to the screen, Wayne.
Pushing the boundaries of our system.
Yeah, just minimize the VM. Everybody hang on for a second. Wayne is experiencing some technical difficulty here. Oh, you got it. All right, we're back. We're back on this Connected Components Workbench screen. And I've already connected the drive to the computer over Ethernet, and RS Links is running and configured. So here on this screen, I'm just going to hit Discover, and the software is going to pull the data from. Well, come on. Well, is it going to do what I just said it's going to do? Of course it is. All right, here's our Ethernet driver, and that's the VFD at IP address number 51. Hit OK. Now the software is going to browse and upload all 2,000 or so parameters in this drive. And keep in mind the drive has over 2,000 parameters, but really we only need to put something in about 10 or 12. You don't need to put something in all 2,000 parameters. If you do, you can make a big mess. All right, so now we're connected to the drive, and the status is stopped, the feedback is 0 hertz. So it's just sitting there stopped. Now, the controls on this software show us everything we need to know. This will show all the drive's parameters in numerical order. If I go to all parameters right here, then it's broken down to the motor nameplate data group. And you can find stuff a little quicker this way. Different options in the case of a pump or conveyor. You may want to set it to coast, to where when you tell it to stop, the drive will just stay around. This one will leave it on ramp. And if we're configuring some braking, on figure right here. We're not going to get in right now. The direction test. This prompts you and hit. So I hit the jog. The drive accelerates. Most of the time, we're going to come and set that to revert disable. That just keeps people from accidentally driving and unscrewing the impeller out of a pump or causing some other kind of damage. 10 seconds to do for right here. And this minimum forward speed, a lot of times with the TEIC motor, this just something to keep in mind. The motor will have a minimum speed. He wants to see that motor run just to make sure it's able to move air and cool. The drive can on, it'll fix up and run the speed references 0 to 60 hertz at 0 to 10 volts. So from 0 to 10 volts, because this is just that our speed reference is working. the enable input, there's a whole lot of functions here that we can use for we can assign other digital inputs to. Here we can go ahead and accelerate it, take it on through its paces. Take it back down for drive configuration. So now someone should have a question. Yes, sir. Tight. But you didn't want to break it, but you just had to keep it taut so they could spool it up. So either that or it can monitor the torque and you give it a set point and you tell it how tight to keep it. If you tell it to get too tight, you can break the cable or break your monofilament. You tell it to get too loose, you can have some sag. So you kind of play with it a little bit.
They'll have a floor with a watch. You try to increase the horsepower on it, and it won't do it because it sees that there's a certain deflection in the shaft. Try to maintain that torque so that you don't.
Like a shear pin type thing?
Shut it down. So
yes. Right. And there's torque limiting features. If you get yeah, Yeah, we'll defer that one. Anyone else? I know we kept this one very, very basic. Now, if we want to go deeper into it, we have a little time, we can.
Yeah, online guys. I know at least on my computer keeps crashing on for some reason. So if you can, if you have a question,
If you need to.
I'm sure we had audio issues on the online, but my computer kept dropping off. So I apologize if there was issues on during some of our was streaming the internet quality issue, and it was just like shut the whole thing.
Itself to the motor, and that contributes to the application. It's
And we're here to help you answer any questions you got. So thanks again. We'll wrap it up. Thanks for coming out and for joining.